Hello, everyone, and welcome to this important webinar on engineering sustainable food systems as we recognize the World Engineering Day for Sustainability. It is a pleasure to be here with you today. It's an absolute honor, and more importantly, it is a necessity that we gather today to address one of the most urgent challenges of our time. I'm Ife Wakano from IntelliDigest, and I'm very pleased that you're able to join us today. And I'll be moving on to deliver the keynote speech for this particular event. We are facing very challenging times across the food system. And for us to be able to engineer food system that works for all, that ensure that more people have access to good food, we need to take a very holistic approach to addressing the different challenges we have across the food system. The global food system is at the critical juncture, and the decisions we make today will determine whether we engineer a future of abundance or face escalating crises in hunger, malnutrition, and continued environmental degradation. It's very staggering in terms of what these challenges look like. Over 700 million people worldwide suffer from hunger, while over 3 billion people cannot afford a healthy diet. For most of us, we do not appreciate or understand the fact that 1 in 5 deaths is caused by malnutrition. More importantly, 1/3 of all food produced globally for human consumption, which is around 1.3 billion tons, are wasted. Agriculture consumes 70% of the world's fresh water, yet water scarcity is a growing crisis threatening food production in many regions. Traditional farming methods deplete 30% of the world's arable land. When we talk about traditional farming methods, we're talking about conventional monocultural practices. And these practices require the use of intensive chemicals, causing long-term soil degradation and biodiversity loss. Food production accounts for nearly 30% of global greenhouse gas emissions, accelerating climate change, which in turn disrupts food supply chains. Now, with rising populations, erratic weather patterns, and increasing resource constraints, our current food system are simply no longer sustainable for us. We may have had several times where all these challenges have been outlined, but what we really want to focus in this particular webinar is looking at how engineering solutions, engineering innovations, technology innovations, science innovations can help us address some of the challenges we have across the food system. Now, science, technology, and engineering offer us an unprecedented opportunity to reimagine how we produce, distribute, and consume food. Innovation is our most powerful tool in ensuring that everyone, regardless of geography or income, has access to safe, nutritious, and sustainable food. What type of innovation are we looking at? In what ways have we seen innovation helping to drive change across the food system? A key area is around AI, artificial intelligence, and big data in agriculture. By using smart precision farming techniques, we use AI and machine learning and IoT sensors to optimize crop yields. This also enables us to plan better, being able to match the demand and the supply in the most efficient way. And this also helps us to reduce food waste. But also looking at the use of satellite data, that is helping to understand better the climate changes that are occurring, the weather patterns, and helping farmers to plan where to grow, how to grow, and when to harvest. With all these advances in AI and big data being applied in agriculture is helping us to move on a long way in improving the way we produce food. but more importantly also it helps us to improve the way the food is distributed and also how we consume the food. Now we talk about controlled environmental agriculture. This could be in the form of greenhouses, in the form of hydroponics, and also in the form of vertical farming. This way, by combining these different methods of farming, it means that we can have continuous supply of the different food that we need. That doesn't mean that we don't need to factor in the importance of seasonal growing and how that could help address some of the climate changes that we have. But what it does in terms of using some of this control environmental agriculture, still linking them up with big data and IoT sensors, is that it improves the efficiency of production. It ensures that we have high value produce locally. And in most cases, it reduces the water usage in food production. And it also helps us to reduce the carbon footprint of food in terms of transportation, because the more we can localize and decentralize food production, the better it is for everyone. Now, something that's also very important is in terms of diverse food production. How can we ensure that we can reduce dependency on meat and improve diversity in terms of crops, arable farming? How do we increase the presence of grains in growing food, and how do we interspace the growing of food in a way that we can ensure integrated pest management, which means that we will then have less demand for chemicals and we will have improved yield, because then the nutrient retention becomes a lot better. These are the things that using data and using improved modeling systems, we can model this diverse food production. We will know when the farmer needs to grow different things on every piece of land. So if a farmer has a piece of land, they can break them into different grids and they can grow different crops and be able to serve their community. And they can also do this more in a very local way, that the food is more accessible to those that need. And also when we talk about alternative proteins, I think it's important to look at how alternative proteins can help us meet our nutritional demand, and how can we move away from ultra processed food into more fresh produce. How can we reformulate some of the our cooking recipes to encourage the use of fresh produce in what we're cooking and what we're eating. And also that will go a long way to improve access to diet, access to nutritious food, and help people meet the daily nutrient requirement, which is essential for staying healthy. Now, another important area, which when we talk about the impact of the food system on climate change, is the amount of food we waste. That's just unbelievable. It's just completely unacceptable that we produce so much and we end up wasting so much of that, because that way we produce food also leads to the degradation. So how can we engineer solutions that help us to prevent food waste in the first place? When we talk about food waste here, we talk about food waste and food loss. So both the food that we waste before the farm gate, which is the food loss, and the food we waste after the farm gate, which is the food waste. So how do we prevent a lot of food loss and food waste, so that when we grow food, most of the food we grow can end up on the table for a lot of people to have access to good food. So what we're doing, for example, at IntelliDigest is developing an automated bio-upcycling machine. This is building combination of artificial intelligence, IoT, green chemistry, enzymatic biocatalysis to enhance the recovery of bionutrient from food waste, so that it can be used locally. But more importantly, by creating an online platform that helps us to connect the producers of the food and also people who grow the food, the processors of the food, that's the growers of the food, and the people who use the food, whether restaurants, households. It means that we can have a circular food system where information, data drives how food is grown and supplied, and the inedible food waste from that process helps to give back bionutrient to the grower so that they can grow food in the most sustainable way. And also the data from the end users that eat the food can help the farmers in planning and optimizing the way they grow food so that they can meet the demand of the end user. So there is a very clear importance in terms of how we relate with the end users and the producers, and more importantly, shortening the supply chains. That is one of the ways we can use innovation engineering to help the food system to heal and to get better. Now, moving on from food waste solutions, the other point that technology can help us with is regenerative agriculture. I'm sure you're going to hear a lot from our speakers today talking about technology engineering solutions that are helping us within the agroecology regenerative agricultural practices. So please stay tuned for more insight on that. But we just need to develop machineries that can help the agroecology sector, the regenerative agricultural processes. We need to help that to thrive, and we need to also create systems that make this work. I'll touch on, I've touched a lot on the data, use of data and big data and AI, but more important also is making sure that that data is transparent. People can see how the data is used. So if someone is providing their data, we're providing data we're using the data in a very ethical way to improve the wider society. So I think this gives you some insight to potential areas that technology and innovation can really help us to drive changes across the food system. But more importantly, we do have a role to play, each and every one of us, and especially those who are policymakers, because these innovations are already revolutionizing food systems, but they will only succeed if we take bold actions, and that will also ensure that farmers, policymakers, scientists, entrepreneurs, and consumers collaborate to drive a systemic change needed. It is important that government and mostly the policymakers in our midst today will take make the effort to support research and policies that incentivize sustainable food practices. And businesses must invest in climate smart waste reduction innovations, and consumers must demand ethical, sustainable food choices. Now, we stand at the defining point in history. Engineering is not just about efficiency, it's about equity, it's about resilience, and it's about survival. I'm very pleased that we're discussing these key innovations today, solutions that are enabling us to change the food system. And these solutions are going to drive impact in our societies. Let us commit today, not just to discuss solutions, but implement them. Through innovation, collaboration, and bold leadership, we can build a food system that nourishes both the people and the planet. Thank you so much for joining us today. And please stay in touch with us and stay with us through the webinar as we get on with the rest of the agenda today. It's been a pleasure to be here with you. Thank you. Okay. Hello and welcome back again. And I think what we will do at this point is to reshare the slides for the participant for the Global Agri-Food Techpreneur Program. And because I noticed that we had a bit of a technical issues that the slides were not showing before, so I will just quickly reshare them, and hopefully that will Hello, everyone, and welcome back again. I really want to congratulate the participants selected for the Global Agri-Food Techpreneur Program. We'll take a quick break now, and then we will return back to carry on with the speakers for the webinar. Thank you very much for joining us. Hello, everyone. I think before we get on to speakers presenting, it'd be nice to kind of get ourselves through a quick brain exercise. So I will quickly put up this question for us to consider. What I think the question is, what are the innovations that we expect to drive changes across the food system in the coming years? If you can drop your message in the chat or comment section. That would be great. So what are the innovations that we expect to drive change across the food system in the coming years? Let's just give ourselves a big, quick brain exercise before we move on to the speaker presentations. So I'll give us at least about 5 minutes to do that. Well, 4 minutes to do that, and then we take the second question before we move to the speaker, our next speaker. So what are the innovations we expect to drive change across the food system in the coming years? Please put your answers in the comment and the chat section. The question is also in the chat section for you to look at. So what are the innovations that will drive change in the future across the food system? So I encourage you to please engage with that. Drop your questions in the chat, and we will start the speaker presentations at 13:40. So we're giving ourselves 4 minutes to kind of do some brainstorming here. So please drop your answers in the chat, and we will be able to go through it. Probably when we're going through the Q&A questions, we'll highlight that. Thank you very much for your comments and your contributions. We just have a second question, and the question is, which stage in the food system requires the most innovation? Production, distribution, processing, and consumption. Which stage in the food system will require the greatest innovation, and where should resources go to across the food system in the future? So please do put your comment in the chat. We will also put the question in the chat for you, and we will show it on your screen. Well, I will encourage us to keep dropping our comments in the chat while the presentation is going on, as well as also drop your questions and your comments for the speakers in the chat. So to help us move on, I will introduce our next speaker. And with that, I want to bring Bill Gay to the stage. Welcome, Bill Gay. I'm very pleased that you're able to join us today. I will do a quick introduction for you. Just give me a minute. So Bjorge works with UNIDO, and she's going to be joining us today to talk a lot about the work that she's doing. And Bjorge is a project associate at the United Nations Industrial Development Organization Division of Energy and Climate Action. She is working with the clean cooking team, and she's also part of the secretariat of the Council of Ethanol and Clean Cooking. Bioge holds a master's degree in policy, specializing in governance. And over the years, Bioge has engaged in diverse fields, contributing to projects related to the EU policies, circular economy, migration, women's empowerment, and climate change across various cities in Europe. Her expertise lies in developing and implementing sustainable solutions that drive inclusive and environmentally responsible policies and projects on a global scale. So it's really an honor to have you here, Bioge, with us, and I will let you carry on with your presentation. Thank you very much.
Thank you, first of all, for having me. And I will share my screen with you. Can you see it right now? Yes, you should be able to see it. So yes, welcome everyone. Yes, perfect. I would like to welcome everyone again. Today I will talk about sustainable clean cooking solutions and the work that we are doing in UNIDO. So first, I would like to give a brief overview of the organization, the United Nations Industrial Development Organization, so also known as UNIDO. UNIDO is committed to promoting inclusive and sustainable industrial development for creating shared prosperity, also advancing competitiveness while safeguarding the environment. So this the organization focuses on creating this shared prosperity and envisions a world without poverty and hunger, where industry drives low emission economies, improves living standards, and preserves a livable environment for present and future generations. And the goal is to create low emission economies, as I told you, but the crucial principle is leaving no one behind. So I work in the division of energy and climate action, where we provide clean solutions to clean energy transitions of the industrial and also household sectors, and to reduce this carbon footprints and promote energy efficiency. So why clean cooking? First of all, about 1/3 of the world population, which is nearly 2.1 billion people, still lacked access to clean cooking fuels or technologies in 2024. So they rely instead on solid biomass, kerosene, or charcoal as their primary cooking fuels. So annual CO2 emissions from cooking, from cooking, are estimated to have reached 1.69 gigatons in 2020, which is more than the entire aviation sector. So we are talking about the really big emissions here. So cooking emissions are also responsible for 50% of the black carbon, which is also a major contributor to the climate change. So achieving universal access to clean cooking is not just a public health issue, but also can be a major opportunity for the climate action. If fully implemented, clean cooking solutions could help reduce up to 1.5 gigatons of CO2 emissions by 2030. However, of course, achieving this universal access to clean cooking by 2030 would require an annual investment of around $8 billion, which represents actually less than 0.25% of the current global energy investments. So, of course, to address this funding gap, innovative financing mechanisms are needed or must be developed, and this is also where we are taking steps. So here, this table on the left side shows various cooking methods based on their fuel efficiency and also CO2 emissions. So as you can see here, traditional biomass based cooking methods such as wood, residues, dung, charcoal are the least efficient and have the highest emissions. For example, here, wood stoves have an efficiency of just 11% and emit nearly 110 grams of CO2. And charcoal is slightly better, but still an environmental burden. Moving toward modern clean cooking solutions, drastically you can see reduces the emissions and improves efficiency. For instance, biogas cooking has at 55% efficiency. And lastly, the gasifier stoves perform even better, making them one of the cleanest options available in this table. So next to the table, we have a global bioenergy consumption breakdown in 2020. We can see 6% was used in electricity generation, and 7% went into transportation fuels, 12% was used in heating in buildings, and 25% supported industrial heating, and 54% was still consumed in traditional biomass used for cooking and heating, is also highlighting the urgent need for cleaner alternatives. So before I talk about the fuels and technologies, I would like to talk about the impact of the current scenario. So polluting, open fires, and inefficient stoves cause many harmful impacts that can hurt the economic and social development in many countries, especially in industrial countries right now. For instance, exposure to household air pollution from burning wood or charcoal, coal, kerosene, as I mentioned, is a leading factor for diseases, including childhood pneumonia, chronic obstructive pulmonary disorder, heart diseases, stroke, lung cancer. And also there is an emerging evidence that when a pregnant woman are exposed to indoor household pollutions, air pollutions, their infants are more risk at stillbirth and having low birth weight and decreased lung functions. So even only in Africa, around 500,000 people in general having this premature death problem per year. So this is all linked to indoor household air pollution and lack of course, access to clean cooking solutions in general. And globally, nearly 4 million people die prematurely every year from, again, illness attributable to indoor household air pollutions. When we come to environment, of course, depending on solid biomass fuels, like how they are collected, the lack of access to clean cooking also contributes to the deforestation. So, for instance, the worst effects mostly concentrated in the places like East or like Southern Africa, where large populations increasingly rely on these forests. This can also create a food stress in the end, because there are some regions where fruit trees are cut for just firewood. So we are not talking about a small loss. According to the International Energy Agency's report, this problem results every year a loss of forests size of Ireland. So we are really talking about a big deforestation issues here. And economically, of course, last but not least, households without clean cooking solutions, they have to or prefer to spend average of 5 hours per day collecting fuels and also cooking. So this is also causing loss of time and also productivity problems, which creates a huge economic costs in the end. And additionally, these daily trips to gather firewood expose especially women to the risk of violence and assault, as they have to sometimes leave their communities to search further. So where is clean cooking in food system? As we can see here in the flow chart, it shows like clean cooking can be found from pre-production to consumption stage. So in the pre-production stage, solutions like biogas from biodigesters encourage this organic fertilization and this kind of innovative agricultural practices. And during the second stage, sustainable food production, clean fuels and stoves can help reduce greenhouse emissions and prevent environmental degradation in general. And clean cooking solution also support sustainable food processing and distribution by reducing harmful air pollution and improving livelihoods in households, but not in only households. It can be also commercial kitchens or institutions. And in terms of sustainable food consumption, of course, affordable clean fuels and stoves contribute to better food security and also improved nutrition. And lastly, agricultural waste can be repurposed as a clean cooking fuel source, reducing this food loss and waste while promoting a circular economy. So in conclusion, we can see that clean cooking is a really powerful tool to building more sustainable and resilient food systems. And here you can see what technologies and fuels are clean. I think it's a really clean flow chart that you can see. This figure shows the different kind of fuels classified in polluting or clean fuels. And clean cooking technologies, of course, come in different shapes and sizes and may use different fuels or different approaches. So how do we know that they are either clean or polluting? So it also depends on the, of course, the World Health Organization's definition of clean cooking technologies. So they are defining clean cooking technologies as the safe options for the users at the point of use. So it depends on cooking fuels and cooking devices that attain the fine particulate matter, and also carbon dioxide, of course, monoxide levels. So these levels should be under the recommended air quality guidelines decided by the World Health Organization. So what are those? Only a few technologies, as you can see, meet the cleanest standards here, such as like electricity and LPG, alcohol fuels, including ethanol, solar, and natural gas. Here, this figure shows how different technologies are classified under the multi-tier framework for the energy access. So there are also different traditional technologies that oftentimes are easier to accept and afford compared to the cleanest one. So the cleanest one doesn't mean that like it's going to be the most affordable and the easiest to reach. As you can see here, tier 0 and 1 is representing no access to clean cooking solutions in general. And this includes open fires and traditional stoves using firewood, charcoal, or dung. And these stoves have very low efficiency, less than 20%, you can see. And also poor ventilation, which is creating poor household air pollutions, and also require over 7 hours per week for fuel collection and cooking. So it's also time wasting. And the health, climate, and gender impacts are severe. And although the upfront cost is low, fuel collection takes a significant time, and also health-wise, their well-being. And the second one is tier 2 and 3. We call them improved clean cooking solutions. So these are more efficient cook stoves, such as rocket stoves or natural draft gasifiers, which you can see goes up to 40% of efficiency. Ventilation is better at the household, and you need to spend less time than 7 hours per week compared to the first one. And it's less of a burden, especially on women and children who stays at home and getting affected by it regularly, but still indoor air pollution may still be a concern. And lastly, tier 4 and 5, modern cooking solutions. This includes, as I told you in the flow chart, like includes electricity, biogas, and ethanol. These are highly efficient and require minimal time for the fuel collection, which is less than 1.5 hours per week. But the problem is upfront costs can be higher. The long-term fuel expenses are more manageable, making up less than 5% of the household expenditure. So the fuel are going to be cheaper, but you need infrastructure, like you need to somehow deal with this first initial expenses. And of course, as I already told you, negative health, climate, and gender impacts. So here you can see this the problems or in front of adoption of clean cooking technologies. So how do we see the adoption rates in general? And adoption rates of clean cooking technologies vary, of course, like significantly across the regions, countries, communities, influenced by several factors. So here, awareness and education, the first thing. So the lack of awareness about the health and environmental benefits of clean cooking is a major barrier. So what do? We do have like education campaigns to inform communities about the advantages of adopting cleaner technologies. And behavior change strategies and communication is also essential for like changing these cultural norms and barriers and accelerating adopting modern technologies. Secondly is, as I told you, infrastructure and distribution. And here, poor infrastructure and distribution networks prevent accessing these clean cooking technologies, especially like in the rural areas. And thirdly, financial constraints. As I told you again, like high up costs may create a problem. So maybe, like a different kind of policy and regulatory frameworks can help, such as subsidies or like different policies to overcome this barrier. And finally, the supply chain development. It's also to strengthen the supply chain and ensure like more reliable delivery for both fuel and appliances. Here, I will quickly pass this, and I will quickly explain what we are doing in UNIDO. So we have a program called Global Impact Program for Clean Cooking. And here we aim to accelerate adoption of clean cooking solutions through a technology deployment, capacity building, and innovative financing, and also strategic partnerships. And we have two major tools, which is the first one is child projects, and the second one is the Council on Ethanol Clean Cooking, which is CCC, where we try to bring together key stakeholders to pursue common action towards a sustainable and just energy transition to achieve this clean cooking. So the program's objectives, as I see, I have less time than I thought, so I will try to wrap it up. And this is an overview of what we are doing under this Global Impact Program for Clean Cooking. And as you can see, we are giving technical assistance, studies, policy, or regulatory support. So this can be as a roadmap maps or behavioral communication strategies. The second one is capacity building and knowledge sharing. And a third one is technology transfer, networking, and advocacy. And we have, as I told you, child projects in Africa and Asia. And we are trying to mobilize resources for the long-term impact, so it's also can keep the sustainability of the system itself. And finally, the Council on Ethanol Clean Cooking. And I will talk a bit about the council. So we are bringing together key stakeholders, as I told you, for clean cooking. And we are currently open, like as membership-wise, to developing countries, least developed countries, small island developing countries, development partners, donors, industry associations, private sector, research and development organizations, and think tanks. And we have currently 23 member countries. And as you can see, like every year is getting more and more. We have, even in 2025, we have 2 new member countries. And we have also partner members, so you don't have to be a country in order to apply for this. And you can also, if you're thinking that somehow we can connect or like have a strategic solutions, you're all so very welcome to send an email. And I will quickly leave this presentation with saying that we are also having a webinar on 12th of March. On alternative feedstocks for ethanol production for clean cooking. So if you're interested in either like this webinar or any partnership membership opportunities, you can always either go to our website or send us an email. Thank you. I think you're muted.
Thank you. Fantastic presentation. Thank you so much, Bioge, for sharing that insight. Really appreciate that. Please drop your questions in the comment in the chat session, and we will be able to share the questions with the speakers during the Q&A session. Bioge, if you can provide the link to the webinar you're talking about, I will be able to put in the chat. So please send me a link and I will share that. Great, thank you. And I think moving on to the next speaker, Asma, if you're ready, let's do this. Just a minute. Hello, Asma, you're welcome. How are you?
Oh, hi, thank you. Thank you, Fenua. Yeah, I'm good. Thank you so much for having me.
Yeah, great. So I'll do a quick intro for Asma. Asma is a strategic business developer with over 10 years track record in developing and commercializing cutting-edge technologies solutions worldwide. Asma has a passion to advance the field of robotics and automation and create disruptive solutions which can solve critical problems in the society. Asmat has completed his MBA from the University of Edinburgh and has previously worked at the National Robotorium in Edinburgh. Currently, Asmat is working as the Business Development Director at Extend Robotics, developing the most intuitive human-robot interface in the world. I think it's going to be quite interesting. Let's hear more about it, Asma. Thank you.
Thank you so much. Let me just share my screen here.
Yep.
Okay. I think this video has started. Am I sharing this video?
Yes, you're sharing a video.
Okay. All right, it's fine. I can start with the video, but I'm just trying to play it.
The video is showing. You just need to play the. You need to click the play button.
Right. It's playing?
Not yet.
Sorry, I think.
It's okay. Okay. Yeah, I think it's the video you want to do first.
Sure. Let me try the slides first then.
Okay, that's fine. I'll try that a bit.
Okay. Is it on the screen?
Okay, I think the video has started playing. Sorry. Hello, are you still there, Asma?
Yeah. Yes, I'm here.
Okay, great.
Video.
I think the video is also playing, so I'll try to add it and see if that works. I think it's just trying to load. Yeah.
Okay.
Do you want to try to? I think probably is the size is struggling to show.
Okay, let's try the slides then.
Okay, great. I'll do that.
Or I can share my screen. Okay.
I think probably you can try the share screen option because.
Okay, let's do the slides first then. I think the slides are
That's
on.
fine.
Can you see the slides?
Yeah, I've got it on.
Okay, thank you. Sorry for the mishap. The video is too large, but I'll try it at the end of the of the deck. So thanks again. So I'm Asmat. I'm the as mentioned. I'm working with robotics and have a passion for deploying robots. We're currently developing robotics, and I work in the industry. So I started working in the research at National Laboratorium, and now I'm actually passionately working and deploying this for industrial use cases, and agriculture is one of those primary use cases we have. Uh, so where we are in the industry right now is that industry and society is we have a situation where we're transitioning from repetitive robotic tasks. Uh, uh, for example, in factories, you had robots to do like pick and place of different tools, and then being able to complete a task, which was you would be able to find these robots in factory environments, and there would be hundreds of robots, each doing a very simple task. From there, we are moving to a scenario where a robot would be needed to do multiple things, and that would require some intelligence. Also, the environments are more complex, so we are moving from these static environments to more dynamic environments, where there is lots of different variables. So this is the current scenario, and this is also a challenge for the industry, because when we are deploying these in these different varied unpredictable scenarios, the robots need to be smarter and require much more versatility and some specific toolkits. So this sort of agriculture falls in one of these categories, because we are trying to automate or some of these tasks in agriculture, but there is lots of variables. There's complexities of the fruits, uh, there is this different every fruit or plant has a different landscape, And so how to deploy the robots and be able to operate them is a challenge for the industry. And also there is a challenge on identifying the fruits themselves, because currently there's lots of requirements, but then we're not being able to deliver on them because of the lack of technologies that are out there. So from the robotics industry, we're developing this, and specifically our company, Extend Robotics, has developed the technology is based is developed to address these specific problems. So the problem that is high variability and hazardous environments, and how we address them is through this accessible uh, system technology. So for operators or industry or society to adopt robots, it also has to be user-centric, accessible. So that's one of the things. Our system is accessible, as in like it is easy to find, it is easy to set up, and it doesn't require a lot of different hardware. So it's easy. So you just need a headset. So if you know Meta headset or HTC headsets, so it's very easy to find, readily available off the shelf, and a farmer can just buy the headset and be able to connect the headset over the internet to our software. So that's the first part. The second part is it's easy to use, and it's a gamified technology. So a person doesn't have to go through a lot of like coding and learning different software to be able to control this robot or train this robot. Through our software is just a plug and play. A person can be sitting somewhere else.
We've lost Asmat briefly. I'm sure there must be some internet connection challenges. While we wait for Asmat to return and continue the presentation, I would like us to take time to look at the innovation questions in the chat. Please do try to respond to the innovation questions. And great to have you back, Asmat. We'll just carry on from where we stopped. Yeah.
Where was I? So here. Uh, so it's a gamified technology so it can be it is intuitive and immersive. So, and it's 3D, full virtual reality. So if you have seen some of the movies a couple of years ago, for example, 10 years, 10, 15, or 20, more than 20 years ago, actually, The Matrix, or those movies where you can get into an environment and sit in somewhere else and be able to be in a different environment completely. So that is almost a reality now. So with our software, a person can be sitting in a different country and be operating a robot in the UK or wherever that is required through the internet, and it doesn't require a very complex setup. It's a very simple setup. Uh, and it's a gamified technology. So a person could be playing a video game. So you'd be feeling like I'm playing a video game and operating a joystick or hand tracking in a VR simulation. And that would control the robot or train the robot, monitor the robot, and be able to complete a task thousands of miles away. This has a lot of implications, so it can be used for training the person before even going for the real task. But going beyond the training, it can be used for the real world application. So this is a key development in the world, because there is not any other uh, system out there which is fully packaged like ours. The third part is affordable. So it is affordability and user centricity is important for people to adopt robotics, and especially for users like in agriculture, where there is barriers to the cost is a barrier for robots to be deployed. So our system, we try to make it as affordable as possible, so it can be it provides that sort of return on investment for farmers. In terms of the features, I mentioned some of those features, but these are the full list. It's a 3 volumetric telepresence, so it's fully immersive. It is interactive, so you can interact with the digital twin. So basically, it's a digital twin environment where a person can interact with the robot in digital twin, and that interaction will be translated to the real robot. That could be on the field. So this is important because there are when you're trying to pick a fruit or harvest a fruit, there is lots of intricate, heavily precise tasks that need to be completed, and these are currently difficult for a robotic system. So that's where our system comes in with our virtual reality based control and interaction. A robot can be made to do very highly accurate, dexterous tasks remotely. For example, like pruning and cutting a branch at a different angle would require this sort of precision. This was is difficult. It has been difficult before, but with our system, it's now possible. Thirdly, is automation copilot. So every task doesn't need to be done again and again. With our system, a task can be recorded. The data from a task can be collected, and that can be used for automation. So that can start from replicating the exact task, or collecting the data from a multitude of these tasks, and that data can be used for AI training. This data that the operator, while operating the robot, can be used with our software and can be used, and that will enable the robot to learn. So that is another important step that we're taking, is how we automate these processes, and how our system can be useful in that. And then there's fleet management. So you could be managing multiple robots on the field, or it could be multiple robots in different fields through one software. And that's key because, of course, you would need to manage multiple robots and need to monitor them. And ideally, it could be one person managing multiple robots in different areas. And as the robots become smarter, it would need less and less intervention time. Yes. So that's one other feature. And then the last one is the cloud infrastructure that we have in building. So with that cloud infrastructure, it means collecting the data, storing the data properly, utilizing the data with easy access, storage, security, all that included. So those are the few pillars of our technology. Of course, we have consistently building on this, and we want to build the most effective human-robot control interface in the world. Yeah. So we're currently quite widely placed, but very, very focused in agriculture, manufacturing, space, and nuclear. Agriculture, we have this project with the Vineyard project. We are currently working in partnership with Saffron Branch. It's a premium wine producer in the UK. And this project is funded by Innovate UK. It's a 3-year project. We are currently in second year, and the project has been very successful so far. So we are at this stage trialing our robots on the field, picking grapes, harvesting grapes. But hopefully within the next year we will have more results from this trial, and be able to also provide our services to other vineyards across the UK and Europe and other countries also. But we're also getting some other inquiries, including strawberry picking, and then various other fruits. So we are very keen to support the agriculture industry, with our solution. Secondly, we are very focused in manufacturing. So manufacturing is very similar to agriculture. It's a heavily labor intensive industry where there is shortages of skilled laborers or retaining them. So that's where also there's hazard in place. So we are working with projects like 3D printing, but also other projects. In space, we're working with Airbus. There's a project for space applications, and remote maintenance and development of systems. Nuclear, also hazardous nuclear materials handling is a key use case for us. So quickly to go through the vineyard project, the future farming project that we're doing. So this is, of course, the key value proposition from this is robotized farming, which is deploying robots for these farming use cases, which is a step-by-step deployment where human operators or skilled humans could be operating the robot. They don't need to be on the field, but they could be sitting in a room and doing this work. And it could be the work could be scaled. So the skills of the operator or the skilled labor force can be scaled for the robot, and it will be a human robot collaboration to complete the task. And the data from this can be used to digitize the process, to collect data from further data from the environment, and use that data in a digitized ecosystem for a maximum optimized operability. So this ideals like the intuitive failure operation is the first one, delivering value from day one. So the idea is that you don't have to wait for years to make this perfect. From day one, you get a value because there's an operator who is going to be the helping the robot. And secondly, it's imitation learning, so automating by movement and observing the operations. And thirdly, continuously improving the process through a human-robot collaboration. Yeah. So the overall objectives of the process is firstly to reduce reliance on seasonal labor force, which is a problem for the industry, and then how to scale up that labor force. So and that's a prevalent issue that's going on. But through our system, people can be one of the key issues with the industry is and with the labor forces, people are worried that going on fields, they're not comfortable on the fields, or it's a very difficult job. So we make it easier with our system because then people do not have to go on the fields and work. So on the fields, it will be the robots, and people will be able to sit in a comfortable location and do this difficult tasks. So reduce input and labor costs. So this could reduce the actual cost of the production because there would be possibly less labor force required, and also optimizing the skills from the force. Increasing the yields is of course a result from that. So overall, the industry farmers are looking for increased yield and increasing the food production, reducing emissions and environmental impact. Of course, this requirement to go on field and be able to have to work on these difficult areas. This transportation cost. There's various costs involved, which can be reduced through use of robots and our system, and improving the overall crop quality. So that's one of the key issues we're looking at and helping, especially the grape product. So through our robots, there are sensors on the end effector which can detect the ripeness of the grape. It can detect diseases of the grape. So this, because of there's a short time scale within which the grape has to be picked. This is key to making sure that the grapes are picked at the right time. But this could also be for other fruits or yeah, because the fruits with our sensory system can be detected for different various purposes and be picked up at the right time. Yes. So this will picking up this procedure will help improve the quality overall of the crop. Yes, so this is overall the idea, the monitoring, the VR interface, the imitation learning, and then we can provide a custom hardware. So this hardware was specifically made for the grape picking project, but we can build custom hardware for other fruits. Of course, every fruit would need some sort of customization because of the requirements and the variation in the processes and of course the product. So from our company, we can do that. Yeah, this is a picture of our group. Of course, Extend Robotics ourselves, Queen Mary University London, and Saffron Grange Vineyard. But these are the two of the robots. But yeah, we're looking to work further. That is mostly. But I have this other. If I have some more time, I have this other video. Stop sharing.
Yeah, we can try that and see if it works. Do you want to bring it on?
Sure.
Great presentation. Thank you so much, Asmat, for walking us through all that
Thank you.
complex
Let me
systems.
see if I can show you the video because it's very interesting.
Yeah. I'm sure the video will bring to life most of the things you have discussed. So I'm looking forward to watching.
Yes.
Queen Mary University are bringing their robots and their technology, and they're using our vines. And
can you see it?
Yeah. The sound, the video is fine.
Okay.
Our vineyard to help test to find out whether their robots are able to successfully pick grapes. We're very lucky to have a number of volunteers that come and help pick grapes for us, but the ability to be able to pick grapes as quickly as possible is really important for us. So a robot that is able to pick grapes, that's able to work 24 hours a day during what is a relatively small period of time would be of massive benefit.
But the impressive part is that we're connected through the 5G router rather than over a local network, which is a good step to being able to operate this in the field while the operator is somewhere located elsewhere. At this point, potentially in the cafe, but further on, potentially in a different country.
Yes. Yes, that's
that was quite interesting, and knowing what it takes to develop systems like this, I think that's quite a lot of effort to get it to the stage that it can pick the grapes. So thanks for sharing that with us, Asma.
Thank you so much. Yes, I think that was all from me. If you have any questions, please do reach out to me. I'll put my email on my chat, and of course you can reach out through our company. I'll also put the link to our website. If you have any questions, there is the case study on this particular use case on our website. Yes, but thanks a lot for having me.
Yeah, thank you very much. So please stay on for the Q&A session. I'm sure there'll be quite some questions for you to help us to attend to. In the meantime, it's a pleasure to have you here, and thank you so much for the insight you've provided. We'll be taking a little break. There's a load of information at this point for our viewers, so we'll take a quick break and hopefully be back again in the next 10 minutes. Thanks, Asma.
Thank you.
So please stay with us as we take this 10-minute break, and see you soon.
Did you know? 1 in 5 deaths every year is linked to malnutrition. Agri-food production systems contributes over 30% of global greenhouse gas emission. And we waste over 1.3 billion tons of food every year. While we waste a greater part of our time shopping for food we do not need and growing food that we end up wasting. These are some of the biggest food sustainability problems facing the planet today, but it's become easy just to say, what can I do? This is where the World Food Tracker comes in. Through the World Food Tracker, it has now become easier for you to plan to save. By planning your food diary on the World Food Tracker, you will discover locally produced food that nourishes your body and improves your health with zero impact on the environment. And here's how it works. You make your food diary using recipes from the World Food Tracker. And the World Food Tracker will use your recipe details to identify the food items you will use in the meal preparation, then provide you an insight on nutrient composition of the food and the shopping list. Through the Plan to Save campaign, we work with local food producers to ensure that food is produced sustainably. By sharing your weekly shopping list with local farmers, you are helping them prioritize sustainable food production, ensuring high-quality food produce and eliminating food waste. It all starts from your food diary. Join other users of the World Food Tracker around the world to plan your food and care for your health, your wealth, and your environment. Together we can make good food more available to more people and evolve a world where no child goes to bed hungry.
Are you an organic farmer? Do you want to diversify your sales channel? The Woodful Tracker is here to help you, to connect you with local household. Sign up today for free.
Hello and welcome back, everyone, from the break. I hope it was enough time for you to have a quick break and stretch your legs, grab some tea, coffee, drinks, and keep yourself refreshed and continue with the webinar. It's been very interesting to listen to our speakers, Bioge and Asma, and also to congratulate the participants for the Global Agri-Food Techpreneur Program. As we move on the agenda for the webinar, the next speaker, whom will be presenting to us today, will be William Flickner. So I will be introducing William, and also William will be coming on stage to share his thoughts around engineering food systems. And please, William, if you can turn on your camera, that would be fantastic. So here you come, here you are. Thank you for joining us.
No problem, it's a pleasure.
Yeah, so great. I'll do a quick intro for William. William is a graduate agricultural engineer and a member of the Institute of Agricultural Engineering Council. He's currently working as a product and marketing specialist in the UK, previously employed as an agricultural consultant in the UK as product specialist for Class Lexion combined harvesters and AG Exceed autonomous tractor products in Australia. William is experienced in crop and livestock production, product specialism roles, engineering R&D and testing roles, and in the UK, in the engineering R&D and testing roles in the UK, Germany, Australia, and New Zealand. His study interests include the application of agricultural technology in sustainable food production, mostly conservative agriculture, precision farming techniques, harvesting technologies, project management, and managerial psychology. William's professional interests include business management, process development and optimization, sales and demonstration training, agricultural robotics, project management, and developing customer and brand experiences. I'm confident that William has got a wealth of experience that he's going to be sharing with us today. And I do implore you to stay on and let William share with us his experience. Thank you, William, for joining us.
No worries. Thank you very much for the glowing introduction. Very humbled. I'll just share my screen now, and hopefully we'll be able to crack on with the presentation.
Great.
Right. We have the screen. Wonderful.
I'll leave it to you.
Thank you. So, if we are going to work. Wonderful. Yeah, so thank you for the wonderful introduction today. I'll just give you a little bit of a very quick intro to me, a bit about my background, who are Horsch, who I'm currently working for in the UK, and we'll look at our present situation, our current technology offerings, and the future innovations we're looking at going forward. So yeah, as has already been said, I've studied agricultural engineering at master's level in the UK and have some experience in farming, consultancy, R&D, and sales and demonstration optimization roles around the world before I came back recently to settle in the UK. Probably describe myself as a farmer without a farm, like most people in my industry. And yeah, I'm now working as a product and marketing specialist for Horsch UK. So who are Horsch? So we're a German family-owned farm machinery company from Bavaria, very much at the conventional end of machinery, I would say. It's great to hear about all the robotics developments in the last presentation. We're probably not quite in the same sphere at the moment, but yeah, this is where it all began 40 years ago at the family farm in Bavaria, and machine developments actually began a couple of years before by Michael Horsch, the founder, actually building machines on his own farm to solve problems that him and his family, who are farming elsewhere, solve their problems. So the first machine was a precision seeder, which he launched in or demonstrated at a sales fair in 1982 in Munich. First successful machines were quite forward-thinking for their time, such as this. It was meant to be a sort of direct type seeder to enable farmers to place seed reliably in soil under heavy trash in a conventional kind of arable cereal growing rotation. Moved on to some quite wacky looking tractors quite quickly, including this self-propelled seeding machine, which was still in production until 2003 actually. And then this is where Horsch probably started to find their niche, moving into Eastern Europe as it opened up in the 90s, with quite wide 12-meter plus machines. So most of Europe at the time would have been seeding cereal crops with 3 or 4 meter wide machines requiring a lot of power, where this was a wide machine that really didn't require too much power to get the job done. Then had a brief foray into tractors, importing a Russian tractor here and developing specialist tool carriers where you could place tanks and hoppers and things on the back of the tractor, before really concentrating on what would be our mainstay today, which would be implements, so seeding and tillage equipment. So again, in the early 90s, mid 90s, when tillage was probably the main cultivation or the main crop establishment method for cereal crops across Europe, we were actually introducing a direct seeder, as shown at the bottom, which has then informed these two machines have informed our current product line as developments have gone on. We also got into crop spraying quite early on. Again, Horsch being Horsch, always starting big. The first development, there was one prototype, and then the first production machine was an 8,000 litre, 36 metre wide, self-propelled crop sprayer, which was, I believe, the largest in the world at the time. Quite ironic, considering the part of Germany where the company is based is quite small machinery, small fields. But that informed again our future product line. And here's a comparison of where the family farm is today. So at the top you can see the family farm as it was in 1984, and now the site as it is in 2024, with the family farmhouse just down in the corner here. They still live in the original farmhouse and still are tenant farmers on the original farm, while also producing thousands of machines a year. And this is the family. So Michael and Cornelia are still very much running the company and in control, and the younger family members are starting to join, which is wonderful. His brother Philip's involved in the day-to-day running of the business, and Theodore Lieb, the family friend, runs the crop sprayer side of the business. Just to show where we are in the market, I find it interesting, considering what we're going to talk about in a minute, that the company is growing at quite a astonishing rate, which is wonderful, considering it is a very tough time to be in the machinery business with revenues as they are on farms at the moment. I don't know what's going on with this presentation. And what's interesting to me is, well, despite sales growing on around the world and us expanding into world markets, Central Europe and Western Europe is equally growing as well, and still remains a very large part of our sales network. So yeah, production sites in Germany. Here's a little bit more detailed view at the factory and show where Horsch get their developments from. So in the foreground here we can see the Horsch Demo Garden, as it's known. So this is our own R&D and trial site. So there's in-house agronomists that work for the company doing up to 300 plot trials a year, everything from tillage practices to seed spacing, seed rates, different varieties, biological versus chemical controls. And I think since 2017 they've managed to control mice without any bait by using birds of prey. There's quite a lot going on there, and it's a very, very interesting place to go and go and visit. And when you do visit and you're about to walk into the company restaurant for your lunch, they helpfully show you a shelf of pickled worms, which highlights nicely how the less intensive cultivation we do, the more healthy our soils are. So that the more we plough them or till them deeply, the less the worm population is. Oh, and this is just a shot of the sprayer factory, where it's very interesting that about 15 years ago there was only one building there, and now they've extended it somewhat. So horse across the world, everywhere there's a H, we've got a site, either a factory or a distribution centre of somewhat. And anywhere it's red, there are machines working, which is quite impressive, I find, for a company that's only been around for just over 40 years. And what's interesting to me as well is that the Horse family are still very much keen farmers themselves, and in 2012 they purchased a 3,500 hectare arable farm near Prague. And again, many of our developments come directly from spending a lot of time in the field working with them, solving their own problems, which will also be problems for other farmers, and developing the solutions in-house in their own farms, so they know that when they hit the market they are fit for purpose. Similarly, also Horse France is Cornelia's home farm, which again is used very much in the development of direct seeding systems, and has been looking at regenerative farming practices, including use of cover and catch crops, intercropping, bicropping, and many other things. We've also had to mirror this in America to demonstrate that these methods we are developing in Europe are suitable for their soils and their climates, and to really demonstrate to the market that we are committed to not just selling them a product, but selling them an agricultural system, and being there to assist them in that process. Also interesting, when we move over to Brazil, which is a very interesting market for us, and I'll show you some R&D developments from there shortly, because the country is such a vast country. We've even had to invest in our own plane to distribute the service guys across and enable them to get to jobs and produce and give good service to customers when their machines are down. And it's I don't know if we're going to see it in the UK yet, but it's pretty interesting. So our product range would be very much what we call conventional agricultural machinery in some senses. So from tillage machines, disc and tine from 3 to 12 meters, seeding machines from 3 to 18 meters, precision seeders for crops such as maize and sorghum, again up to 18 meters wide. Crop care technology include like crop sprayers from 1,400 litres to 8,000 litres. And what's probably quite interesting is our hybrid farming range, which is not necessarily new concepts to the industry, but it's very much new concepts to us as Horse. So mechanical weeding and mechanical cover crop destruction without the use of glyphosate or without the use of heavy tillage. And finally, another important avenue for us is the intelligence side of the business, which I think will be interesting to some of the participants today, including sort of telematics, mobile control from your mobile phone of machinery, and isobus solutions. So just touching through crop care technology, sprayers, what would be probably quite a standard offering on the market in this sector now would be individual nozzle control. So as we can see, this crop sprayer, part of the boom is spraying chemical and part of it isn't. And the GPS technology is switching the relevant nozzles on and off to ensure we don't double apply chemical where we don't need to. Something that's been more unique to us is doubling the amount of nozzles on a sprayer boom. So we're down to 25 centimeter nozzle spacing, allowing us to spray lower, closer to the crop canopy to reduce spray drift, enabling farmers to spray more conditions throughout the year and enabling to get the chemical applied to the crop in a good fashion, a good timeliness. Various other features include our booms, and you don't get the pleasure of me doing the famous horse dance, trying to demonstrate this with my arms as I'm presenting virtually, but we were the first manufacturer on the market to bring double acting variable geometry booms, which can hug the ground contours. And that's been a very good selling point for us. Again, we're aware that, you know, chemical application is a luxury in agriculture. It may not be around forever, so we need to make sure we're responsibly putting the chemical where it's needed to ensure good efficacy. Further technology that's been very good to us and good to our farmers has been things like curve compensation, so on a wide sprayer. The fact that we can, as the sprayer goes around the corner and the outside boom has to travel faster than the inside, we can vary the amount of chemical being applied through the boom to ensure we get a consistent rate no matter the speed of travel of the boom. And the use of technology such as pulse width modulation, PWM, spraying technologies. Let's skip forward. To ensure that, again, if a sprayer is traveling in a circle or not in a dead straight line, that the consistency of coverage across the boom is true. I'll just play a short video on that. So as we can see here, the sprayer nozzles are not providing a consistent amount of spray. They're varying on and off. And this technology allows us to start looking at spot spraying and patch spraying, as we can vary the individual nozzles application either on or off on different amounts of chemical as we travel across the field. Let's see if we can get to the next slide. So what this really opens up is quite an exciting area for us, because many farms are still looking for, you know, large machines to provide good output in a day, so hundreds and hundreds of hectares per day per operator. And now, instead of applying a blanket application of chemical or fertilizer at one rate across the width of the boom, as we move across a field, we can look at applying more chemical or fertilizer, more product where it's needed and less where it's not needed, or none at all, which is really, and this is without necessarily having to do live spot spraying, but we can load up a pre-prescribed prescription map into the machine from flying a drone or various other data gathering methods to provide, a prescription map which then can be applied simply by the sprayer with no extra stress for the operator at all, saving significant amounts of active ingredient. Further innovations, cameras. We can now fit cameras to the sprayer booms to allow band spraying. So we can either spray the rows of crop or in between the rows of crop, again looking to cut down on the amount of active ingredient, the amount of herbicides, pesticides and fertilizers we're applying to our crops and our environment. So spot and patch spraying, these technologies that we're fitting to the sprayer to allow individual nozzle control and variable application is enabling us to either do spot and patch spraying by flying, like I say, a drone, or using satellite imagery to create a prescription map. And I believe in R&D at the moment, although I'm not able to talk about it, there is some development of online camera technology to live detect on the sprayer and apply a variable rate of product. Just move on to seeding and tillage for a minute. So nothing overly radical here compared to robotics, but what we have been able to create is seeding machines such as the one in the top corner. It's a disc no-till seeder, which can have multiple hoppers on it, so we can apply three different products, 3 different seeds or fertilizers at a time. We can direct drill into a standing cover crop, and then we can even seed different plants at different depths across the row. So we could have an alternating row of wheat and barley as a companion crop, or wheat and beans as a companion crop, or oilseed rape with versing clover, and the combinations go on, which is something that, while the disc culture and direct drilling may not be a new innovation, the ability to easily do seeding into cover crops, residues, and with intercropping and bicropping has been a really good success for us, and farmers have been very fortunate to have that option. Just to show a bit of the background that goes on, the R&D, we have been testing a machine to precision seed cereal crops, which we would not normally look at doing. We'd normally only look at precision seeding and singulation seeding maize and soya, for example, which means we could go to a much lesser seed rate, maybe cut it by 50%. Currently, this is an R&D project, and it's not looking like it's necessarily got a good value proposition, but we'll talk about that a little bit more in a minute. The hybrid farming range, again, as I mentioned, not necessarily new products, but not new innovations in the industry, but new products to horse. And it's been a really good uptake among not only organic farmers, but conventional farmers looking to reduce their herbicide reliance. Or maybe they've got to the point where certain herbicides are resistant, or their plant population is resistant to them. So they're looking at more mechanical systems. Let's play another very short clip here to demonstrate that whilst again an inter is not a new technology, us to use these machines practically in modern cropping systems. So here we have a row lift system. So it means we can now inter hoe as accurately as we can apply a herbicide. The other now for the robots. This is a development project that Horse Germany were working on, which was a 350 horsepower autonomous. Why was that skipped? 350 horsepower autonomous seeding platform, which you could either put a corn planter, a precision planter, or a cereal planter on. Did 2 years field testing, and the idea was the operator would breeds and then would be free to shuttle back to the farm and refill his support vehicle, and then transport the machines between fields. This is not going into production. It has actually been discontinued as a project, but it was a very good learning experience for us. And again, I'll touch on the reasons behind that shortly. But what it did lead into was the horse gantry. So this machine is going to production this year. It's a 24-meter gantry self-propelled precision seeder for the Brazilian market. And there's a 36-meter wide machine in development as well. And the reason this machine has come about and has sort of superseded the other autonomous project is we found that due to legislative requirements and the restrictions on moving autonomous machinery in Europe, there is not yet deemed to be a mass market for the large scale robotic systems. Where this machine was originally designed as autonomous, as you'll notice the top picture, it doesn't even have a cabin. So the idea is for it to work autonomously, or for an operator to be present and possibly control a fleet, maybe 2 or 3 seeders. And we have found that so far it is still pretty handy to have an operator on board or nearby, because there's so much setup and optimization of the machine and fault finding the machine can't yet do for itself. And we don't currently have the technology available to reset it during if there's a blockage or a failure. Just show a very quick clip of it working. Quite space age, quite interesting, and there's definitely some interesting from it in some markets, but it's not something we're ever going to see in Europe due to the physical size of the machine. So what I wanted to finish on is just talking about the value proposition of the technology and automation. What we have seen is, despite all of our seeding technology and fertilization and crop protection machines all being able to variably apply product at different rates, and the use of the pulse width modulation technology, we're not seeing a massive uptake from the market due to the complexity of the systems and actually how the cost it adds. In addition, the telematics as well, we are getting some good uptake in some areas, but fundamentally we can keep gathering data, but if the farmer doesn't see value in it, then they're not willing to pay the extra to run the system. We've also found, like with the R01 project for the autonomous tractor shown on the right of the slide there, that dedicated autonomous solutions seem to be in some areas of food production prohibitively expensive in the lower margin, lower value crops, and that the conventional autonomous tractor setups that can be used with conventional tractor implements do look more cost effective for most at the moment for us. As mentioned, there's many challenges with road transportation, machine setup and optimization, blockage detection with these autonomous systems, and this is where our gantry system for the certain markets does look to have some good potential. And the value proposition of the technology in the low value or low margin crops is a challenging concept, and if the farmer cannot see the benefit, he won't want to pay for the technology. And I just wanted to touch on a final thing. You may notice that there's a lack of conversation around swarm robotic technology here, something I've been very interested in over the years and have touched on briefly before. But the struggles we were having is to get enough penetration on a seed coulter to reliably get a seed into a seed bed at the correct depth with seed to soil contact. We were finding that smaller systems didn't have the weight necessary to penetrate, which is why these larger autonomous systems were focused on. And so we'll see what happens going forward in the market, because there's some fantastic autonomous solutions looking to come through. That was about me done. I don't know if we wanted to do any questions or if I've run over at all.
Well, thank you so much, William. I think that was really good to see what is going on in the sector at the moment. And I think one of the key things we're looking at is how conventional systems can be adapted for more regenerative and agroecological systems. So it's really good to see what's happening in the sector at the moment. It's also important that you mentioned that value proposition is critical for farmers. It's about how do we create values for farmers to ensure that they can make this transition as needed, and also support companies like Hirsch in the technology developments they're making and in the process of that transition. So thank you so much for sharing the work you're doing with us. The Q&A will come after all the presenters have spoken, so hopefully we'll have some questions coming through for all the speakers, which I'll be sharing during the Q&A questions. So please stay with us. Thank you. I'll be introducing our next speaker, Professor Carl. So I will hopefully, Carl, you are with us here. So stop sharing Hirsch, and I will bring Carl to the stage. Great, so fantastic. Carl, thank you very much for joining us. I'll do a quick introduction for you before you carry on with your presentation. So Professor Carl Behredent, sorry if I get it wrong, is Elizabeth Craig Chair of Agri-Tech Economic Modeling at Harper Adams University. He's a founding research group lead of the Global Institute for Agri-Tech Economics and co-director of the Center for Effective Innovation in Agriculture. He has over 20 years industry experience in farm and agribusiness management, consulting, extension, and research. Carl and was a sheep farmer for more than 15 years. Carl core disciplines are in bioeconomics modeling and decision support for farmers, industry, and policy. CAL is currently undertaking research into the economics of precision livestock farming and grazing, robotics, alternative protein and oils, floriculture, regenerative agriculture, and using technology to achieve more sustainable farming systems. I'll leave it to you, Carl, to share a lot of the work you're doing with us, and hopefully a very interesting conversation will follow.
Thank you very much for the introduction, and pleasure to meet everyone today, and I hope you're having a great day. I was very kindly asked to speak about our project, Digitalisation to Support Agroecology. And there's two aspects I wanted to present today. Firstly, provide an overview of our project's approach, and secondly, to provide some outcome highlights with a slightly deeper dive into the economics of a couple of technologies that you might find interesting. So you can see on the screen there's a large list of people there, and on the first one obviously presenting, a lot of the hard lifting in this project has been done by Elias Maritain, our PhD student at Harper Adams University, and it's been a very big project. But let's start. So what are some of the current issues in agriculture? We're all familiar with these. We're familiar with greenhouse gas emissions and contributing to climate change, large chunks coming from agriculture. There needs to be a bigger debate about emission intensity, but that's a secondary debate. There's obviously negative environmental impacts, as many of our previous speakers have spoken about, in terms of fertilisers, pesticides, herbicides, and just in general unsustainable farming practices. But the other thing we've seen is a destruction of habitats. And it was interesting to see these large-scale machines roaming around very large fields. But in the UK, for example, between 1984 and 1993, over 60,000 kilometres of hedgerows were destroyed or pulled out to increase field size to make it more efficient to have large machines. In addition to this, there's been roughly around 100,000 kilometres of tree lines that have become gappy, with older trees being removed and not being replaced, purely from an efficiency and ease point of view. So there's a real challenge here as we're getting homogenisation of the landscape. But there's a couple of other external factors as well, in terms of the link between consumers and producers, the value of the actual food that's produced, and how food security is viewed in a political sense and also a social sense. And that will come more and more to the fore the more we have conflict around the world and potential trade barriers and trade wars. Structurally within the UK, we also have a rural exodus in terms of labour moving out of agriculture, and also succession problems, especially in the light of recent tax changes and in general a neglect of rural infrastructure, which is leading to certain barriers emerging. If we think about the current status quo of agroecology and digitalisation, agroecology comes from the concept largely of sustainable agriculture, which is based on environmental, economic and social principles, and getting the right balance between them. No longer just being a productivist, but also being environmentally responsible, and also society valuing what agriculture does, or food production actually does for society. Part of our project, we use the FAO's 10 elements of agroecology, and I'll come back to that. That's probably the most important development most recently, and it's the framework that we've embedded within our particular project. The other thing that I suppose is very important, and is something that's been evolving for the last 50 years in different forms and different technologies, and has been emerging that long, is precision agriculture and digitalisation, and how it's used to more efficiently use resources to increase food production. And this is essential given the rate of population growth within the world. So farmers are obviously very much concerned about the challenges of being connected to consumers, and the more we develop this, the more we have a longer supply chain. There are obviously concerns regarding efficiency, but then there's also emerging threats regarding data privacy, cultural values, and accessibility. So our current research is focused on how can digital technologies enable agroecology. And so what we've had a large-scale project that started in September 2022 with 12 partners from 7 countries, with work packages predominantly around mapping digital technologies, the assessment of those digital technologies, considering the barriers and enablers of adoption, and then looking to develop roadmaps for those enabling digitalisation to support more agroecological farming. So I mentioned the 10 elements of agroecology, and you can see from what's on the screen at the moment that it covers all. It's very holistic in terms of it covers everything from responsible governance to circular economy, also diversity in the landscape, efficiency, recycling, synergies, resilience, human and social values, cultural and food traditions, as well as co-creation and sharing of knowledge. And it's been really good to hear a lot of the effort going into co-design of technology to meet an end. We embedded that framework throughout this particular project, and one of the first things we did was looking at mapping of digital tools. So what's evolved from the project is a platform that's distilled quite literally tens of thousands of information sources into 51 commercial products, 209 research articles, and 41 research projects, where we have analysed the economic, environmental and social impact analysis. And our colleagues at AUA in Greece have developed this wonderful platform, and I recommend everyone to go and have a look and search through that. So that was one particular stage, and we needed to do that to try and identify which technologies potentially have the greatest agroecological impact. We then proceeded with running a series of workshops, and these largely covered 2 types of workshops. So one set of workshops, 12 technology workshops were developed, and we also did 7 policy workshops in different countries. So the technology workshops were very much about discovering what the agroecological impact of different technologies driven by stakeholders, people who would use the technology, apply the technology, or understand the technology very well in the settings that they would be used. So what are we talking about? So starting on the left-hand side, we've got Harper Adams University, and we looked at 2 technologies. One was virtual fencing, and the other one is using small autonomous machines to do 2 metre wide strip intercropping. Many of our other partners also looked at other technologies. So what was mentioned earlier before was identifying weeds and where to spray. So our colleagues from Denmark looked at a drone-based decision support tool, Thistle tool, which maps where the weeds are within the field, which enables precision spot spraying and variable rate control. We've also looked at room and bolus technology, so just moving clockwise around the images. We've also looked at Yarra N-Sensor. The group at Zalf looked at an app that monitored natural capital and how the landscape was performing within agricultural systems. The group at Luke looked at monitoring green biomass to help determine whether or not the amount of carbon that would be reintroduced into the soil if a cover crop was ploughed in, for example, or just returned into the system. We've also had a couple of robotics studies. So one in particular was looking at FD20, which is a fully autonomous unit, standalone unit that operates 24 hours a day with precision planting, seeding, and precision weeding. We've looked at spray applications using drone systems, precision sensors, and also mapping of tree cover in Portugal. So there's been a wide array of technologies that were looked at. Now I want to introduce to you this particular chart, which is the outcome from our digital tool scoping workshops, where we asked stakeholders to determine the potential impact on an element of agroecology, but also we gathered some information about how confident they were about those different particular impacts. And if you look in the columns, and I'll try and use my mouse to indicate it. So this first one is the rumen bolus sensor, and we can see that it has a very strong efficiency impact, a good resilience impact, but not so good for recycling. And that's because the rumen bolus is very much only persists for the life of the animal. And as we go across, we can see that a large proportion of these technologies very much have a positive impact on efficiency, which is what we would sort of expect. But some of them do have strong impacts in other areas, and this one in particular, HAU2, which is our 2-metre intercropping system using small autonomous machines, is also expected to have a large impact on resilience as well. So there's a lot to take away from there, but part of this project was also thinking about what happens to adoption and what drives adoption and what are the barriers and the enablers. And from this picture on the left-hand side, we used a ADOPT framework, which was developed by CSIRO in Australia, and it involves 22 questions that we used stakeholder group workshops to try and determine the time to peak adoption and also the peak adoption level. Now, they're both interesting things in their own right, but in the bottom right-hand side, looking at this particular chart here, what we really discovered is what's much more important are what are the critical drivers and drivers, enablers, and potential barriers to adoption, given the use cases of different technologies in different contexts. So this was a very important part. All of this is summated in farm level assessments of agroecology relevant digitalisation technologies through our series of fact sheets. And I'm showing you the one in particular from virtual fencing, which we were part of at Harper Adams University. And they will be becoming available soon. So please look up the website and you'll see all of the technologies with their own individual fact sheets, which includes the assessment of the impact on agroecology, but also opportunities and challenges. So now I wanted to do a very quick dive into the economics, if I have time. And this is really important because often we talk about being an agricultural economist in background, we often talk about things like economic gravity, where although it's really good and a lot of farms are very receptive to agroecology, if it's not economic and it doesn't pay, it's very hard to adopt things to achieve social and environmental outcomes as well. So what we did as part of the project was look at the economics of different technologies using an ex-ante multi-objective linear programming approach. This approach balanced economics with social outcomes as well as environmental outcomes wherever possible. And I'm just going to touch on the two technologies on the right-hand side, which is the small autonomous machines for intercropping and also no-fence technology. So this video, what we're looking at here is the hands-free hectare in action. And this hands-free hectare was a fascinating concept in that the engineers at Harper Adams University managed to grow a cereal crop in 2017 fully autonomously with no one stepping in the field, whether it was for agronomic or activity purposes. This was later extended to the hands-free farm, which introduced a lot of other challenges to having autonomous machines running around in terms of people entering the field, animals walking through the field, power poles being in the middle of the field, and all those sorts of things. And it was an example to put it at scale. In the bottom left-hand side, you can see an image of our 2-metre strip cropping experiment run at Harper Adams University. And in this particular image, we're showing the autonomous machine mowing a 2-metre strip of clover lay between winter wheat. And this maximises the edge effects within the field. When we compare autonomous strip cropping just on a whole field sole cropping comparison, we have significant reductions in farm labour requirements because of the autonomous machines. We also get an increase in gross return and an even bigger increase in gross return after fixed costs are considered, which results in production costs dropping. And the reason for this particular relationship is if we look at a conventional set for whole field sole cropping, we're talking about nearly £500,000 for a 200 hectare farm, where for small tractors that are retrofitted for autonomy, the total investment is about half. So that makes a significant saving in that particular aspect. If we then think about, well, what happens in strip cropping, small strips where we're trying to maximise our agroecological outcomes, we again have significant reductions in labour because the autonomous machines can run 24/7, although we're assuming roughly around 10% supervisory time for running those machines, primarily for refill and for incident call out as well. And as before, we also have an increase in gross return and even more increase in return post fixed costs. So this is a combination of labour effects as well as yield effects, as well as the cost of capital effects, if you like. And as has been mentioned before, we do have regulatory issues in doing this, especially in the UK, and these are some of the things that we need to get past or are barriers to the broader scale adoption of small autonomous machines. Just to quickly cover off on the no fence technology, we compared two basic systems. One, so this is virtual fencing technology where each individual animal is wearing a collar. It's GPS located within a field, and as it approaches a virtual boundary, it gets an audible signal before it actually gets an electric shock. So there are animal welfare concerns about this, but the shock being provided by the virtual fencing collar is actually less than what is provided through electric fencing. But when we compare using these very smart collars that give you excellent information and to a very much strong degree, very good animal control, we against a set stocking system where you're not moving animals and you're not rotationally grazing and you're getting lower agroecological outcomes, we actually have an increase in labour requirements in comparison. And because set stocking, you put the animals in the field and you don't go back, where virtual fencing, occasionally you do need to visit the field to make sure that where you're moving the animals to in their virtual paddock, there is sufficient feed and there's water. So there's those sorts of things. But it is less labour intensive than using rotational grazing with electric fencing. So in terms of gross return, it very much so gives a higher production of beef than set stocking because you get benefits from rotational grazing, but it's very marginal in terms of against the rotational fencing using electric fencing. But then if we think about what are the returns after fixed costs have been considered, Unfortunately, the collars as they are at the moment are too capital intensive to justify for intensive lowland grazing systems, and so it's difficult to justify there at the moment. If we think about another application, which is probably the one that's much more popular, is under conservation grazing, where we assumed you couldn't put up electric fences. So we're comparing no fence collars to set stocking of a conservation grazing area. Under the set stocking scenario, you're not protecting the landscape. And in this particular case, we assumed 10% of the landscape we wanted to protect. Even though the collars were very effective at doing that, it still remains a fixed cost challenge, even with countryside stewardship payments in the UK. So there is a capital cost challenge with no fence technology, but it offers a great potential to increase agroecological outcomes, especially in diverse and challenging landscapes. So the last part of our project, and this is my final slide, we held stakeholder groups to go through a process of identifying opportunities for digitalisation and the degree of intervention that we would need to support that. We identified threats and barriers to digitalisation, and again, the degree of intervention to overcome those. And in the end, we, through this process, we identified actions and policy for digitalisation to enable agroecology. And ultimately, we're looking to develop a roadmap for English policy to improve the potential for digitalisation to enable viable agroecological based farming systems. And so this is a work in progress, and I encourage you to keep up to date with what happens in our project as all of this becomes available. So thank you very much.
Fantastic. Thank you so much, Carl, for sharing that project with us. I think there's quite a lot to take from there in terms of technology solutions and what the project was aiming to do and the outcome of the project. So very much appreciated. So I think we will be going to the last speaker now. Please do stay with us. Drop your questions in the chat, and we will have the last speaker who will present before we go to the Q&A question session. So with that, I will bring Daniel Evans to the stage. Hi, Dan, how are you?
Very good. How are you?
Yeah, great. It's been quite an interesting session, a lot of insights and a lot of things to think about. So it's great you helping us to wrap up the presentation today.
I'll give it a go.
with a very exciting project. Before you go on, I would love to introduce you. Dr. Dan Evans is a lecturer in soil science at Cranfield University, and he is a director of Urban Cultivate Limited. His research focuses on soil formation, planetary health, and sustainability, with a particular interest in accelerating soil creation for urban greening. His work on urban food growing has led to the establishment of Urban Cultivate Limited, through which he collaborates with growers, chefs, city planners, and policymakers across Europe and North America. Dan's interest in soils began in 2012 during Royal Geographical Society scholarship in Alaska. He later earned a first-class degree in physical geography and completed a PhD at Lancaster University, producing globally significant estimates of soil lifespans. He led research disproving the claim of 60 harvests left. Interesting. Love to hear more about that. And pioneered drone-based synthetic aperture radar for soil mapping. Dan is recognized for his contributions and was elected to Sigma's XIS Scientific Research Honor Society in 2023 and awarded the Enricher Medal in 2024. He co-designed the UK's first soil science apprenticeship and represents early career scientists in multiple organizations. Passionate about science communication, Dan has delivered TEDx talks, public lectures, and media interviews, and launched an educational soil science talking bench in 2023. Great. Thanks, Dan, for joining us, and I'll leave it to you.
Thank you so much. That's such a high bar, I think, to the expectations are high now, so I better share my screen.
Yeah.
Successfully. Let's have a look. I think this will be, there you go, brilliant. So hopefully you can see this.
Of course.
Maybe even
yeah, perfect.
Change that. So hopefully you can see that. Thank you very much for that lovely introduction. And it's been a very fascinating couple of hours. I think it's been a really interesting exploration of different technologies on this World Engineering Day, and I'm happy to round off the series of talks and enjoying the panel discussion after this. And I'm going to be speaking about tomorrow's soils, which are in many ways things we should be thinking about today, specifically within urban spaces, and I'll explain why in just a second. So just to say that I'm here with two capacities this afternoon, both as a lecturer in soil science at Cranfield University. I won't read all the way through that because you made a good job of that a minute ago. But the second aspect to my life, in a sense, is the director of Urban Cultivate, which is a new consultancy for urban food growing projects. And one of the things we try to do in that consultancy is to triangulate various types of data, be it environmental, spatial, and socioeconomic data, to make effective decisions for where, how, and when we should be implementing food growing in urban food spaces. So in a way, kind of my interest here in both camps is within soils. My expertise and training has been in soil science, and it's about that fundamental material of soil that I'd like to speak to you today. Now, often it's the case that we take soils for granted, and perhaps we also take the materials that form soils for granted as well. And I've, in a sense, categorized them here in two different ways. First are the natural parent materials. It's a term we use within soil science to, in a sense, denote the underlying layer of material which creates the soil, which turns into the soil. Often it's bedrock, but not exclusively. It could be any deposit, be it glacial, fluvial, aeolian, dust deposits. Much of the UK soils, for instance, have been formed from these superficial deposits, not necessarily from the bedrock. And then we come to a second category, which is around manufactured parent materials. And these are the substrates and the growing media, which are often used in urban contexts, particularly in urban agriculture and green infrastructure. So it could be the husk of coconuts to the use of zeolite in particular areas. Often these are sourced locally, manufactured locally, and placed locally, but as I say, not exclusively. So why do I start off with that? Well, one of the things that I'd like to talk about today is a project that came out of a cross-disciplinary research fund coming out of UKRI a couple of years ago. And this was a project where we were trying to cut across different disciplines to understand how we can improve the resilience of manufactured soils, engineered soils, for the purposes of urban green infrastructure. We know, of course, that urban green infrastructure is really important in towns and cities, from parks and gardens, private cemeteries, allotments, community spaces, community gardens, and so on. You know, this infrastructure provides a whole host of goods and services to us and the wider ecosystem and the environment. A piece of research that I led a couple of years, actually no, three or four years now, based on a systematic review, showed that green infrastructure in urban spaces enhances the delivery of many ecosystem goods and services, all the way from those regulating services like carbon sequestration, air quality regulation, all the way through to creating habitats, nutrient cycling, and also those cultural ecosystem services that we perhaps don't think about so often, those such as the preservation of cultural heritage, the history that's contained within the green spaces. It is really something that we should be protecting, if not enhancing, in the future. But the overarching idea, this notion, is that for green infrastructure to deliver these services, we need soil. The long-term capacity of green infrastructure to be able to preserve the ecosystem services for sustainable amounts of time, and for them to be resilient to disturbance, because that's the other issue here. We not only think about the notion of sustainability, but the capacity for those to withstand, respond, and recover to perturbations. One of the most important materials we need for that is soil. So we come back to this idea that we need soil, and we need soil in urban spaces, in an environment, in a context where soils perhaps are not naturally forming. Because after all, we've covered those natural parent materials with asphalt and concrete and tarmac and so on. So to deliver the Sustainable Development Goals, some of them have been brought up to this afternoon, and particularly in terms of World Engineering Day, we might be thinking about the built environment, but not only the built environment, the social capital, the human capital that arises out of those natural capitals. And importantly, across many of these talks has been the sense of financial capital, economic growth, responsible production, responsible consumption. Soil is a really valued material in the big link of all these capitals. And so we have to consider how and where we can obtain soils for urban spaces. Now, back to our natural parent materials, soil formation takes a very long time, a hair's width per year on average. But for urban green infrastructure, we need lots of soil, and we often need it very quickly. So we need a different approach for soil generation. How do we generate those soils? Where do we generate those soils? Well, one such example is the as-dug natural topsoil. Essentially, this means stripping from a green field the top 30 centimeters of soil, collating it, perhaps screening it to some extent, but it's more or less soil which is ready to be used. And there might be some cases to be made that it has the vital properties that we need from soil. It might have the carbon, it might have the microbiology already established within it, such that we don't need to add those things later down the process. But those natural topsoils are relatively non-renewable. It takes about 10,000 years, more or less, to create that 30 centimeters of soil. You can strip it off in an afternoon, but it takes many thousands of years for it to form. So it may not be resilient for the wider ecosystem, albeit it's quite a useful, efficient way of getting soil, lots of it, rather quickly. The other alternative here is manufactured soils, so blended mixes of organic and inorganic material, which is often located and combined off-site and then brought into the urban green infrastructure scheme. So there's many terms in the literature for these: engineered soils, fabricated soils, artificial soils. There's many of these, but essentially all of these are soils which have been combined from a number of organic and inorganic streams. Silt, sand and clay are combined together, perhaps with some organic matter, some compost added to create that organic carbon within that growing medium, and then it's installed into the site of your choice. And one of the things that we wanted to do in our project was to establish how resilient these manufactured soils are, how able are they to recover from perturbations. And of course, two of the problems we have here that we found in the project is related to the production of the soil, which is in a sense separate from what happens once it's placed. So let me first go through the production of it, and then I'll take you to the monitoring of it. So a little case study, which I'll go through reasonably quickly. It's a site based in Stratford in London. And there you can see an architect's plan of this site within Stratford, green infrastructure being, in a sense, designed to the British Standard 3882 spec. So compliant with the British Standard spec for topsoils. These were transported, placed to London, installed into these beds and containers. But then something happened. About a year later, the trees which were grown in these soils started to die. And at the end of that summer was a large bill amounting to about £200,000 of dead trees. So what went wrong in this particular environment, this particular case? And remembering that this was 2022, this summer, which was a very dry, very warm summer, particularly within London. Well, the first problem was, as I say, related to the production of the manufactured soil. What we found actually is that to be compliant, you have to have soils which meet various criteria, but these criteria are quite broad. And if we look, for instance, at the compliance range for sand content, for example, a soil can be compliant anywhere between 20% and 90% sand. Well, a 90% sand, and I think in this case it was about 88%, an 88% sand is going to drain water very quickly. It's not going to hold on to that water necessarily well, unless you are adding amendments to it. Which wasn't the case in this particular example. What you'll also notice is that within the BS 3882, resilience as a principle is not mentioned. The focus is on soil properties, not necessarily on resilience and sustainability. It's a tick box exercise in many ways. The second issue is not just about the production of the soil, it's related to the monitoring of the soil. Normally speaking, when soils are installed, they're rarely monitored. And this means that we're unable to assess how they're changing over time, how they're responding to changes in the microclimate. So in many ways, we can't measure the resilience of these soils once they're installed without going back doing monitoring surveys, which isn't the case at the moment. Now, when we went back to this site a year on after they were installed, we found that the soil organic matter content had decreased by 10%. Now, the organic matter content wasn't very high in the first place. So although it was still compliant, it had the potential to fall below those compliance levels. And we also saw some interesting things regarding the metals, which I won't go through now, but obviously in urban environments, contamination and pollution is obviously something we have to be quite careful about. I've put in a few of outputs that came out of this project here on this slide for you to delve into further, and these kind of explain what the next steps would be. First, in terms of the production of the soil, in terms of how they're being formed, these manufactured soils, but also how we monitor them. And both of these are very crucial points in this regard, because although you can create a sustainable and resilient soil, the only way we can really measure that is by repeatedly monitoring them over time, and perhaps bringing the citizens into the picture when it comes to monitoring. Citizen science has a great potential in this case because of the nature, the density of the urban population around these soils that live and work around these on a day-to-day basis. So there's a great potential perhaps for that to happen. So on world engineering data, some conclusions coming out of this study. Well, obviously the demand for urban green infrastructure is only growing. So there's a demand for these urban soils, mass generated and generated very quickly. So the idea is, how do we do this? I think, as I've explained earlier, that there were some questions about the sustainability, about the as-dug topsoils, basically extracting a layer of soil from a field. But if we're going down the manufactured soils route, which is essentially taking different waste streams of material and putting them all together somewhere outside the city and then bringing them inside and installing them, we need to revisit what it means to be a sustainable and resilient manufactured soil for the future generations. There's a very likely need that we need to have a big discussion about how to change the British standard such that it has maybe some modularity for different contexts. And there also might be a need to integrate variables which are directly measuring the resilience of those soils. And whatever happens, I think monitoring soils post-placement is really key to ensuring that they're sustainable and resilient for the future. So it does require some monitoring scheme after placement. You can't just put soil down and leave it alone. It needs to be cared for, like anything else. So I'll leave it there. Thank you very much for listening, and I'll welcome any questions. But if you'd like to get in touch for more information, my details are on the screen.
Thank you so much, Dan Evans, for sharing that experience, knowledge with us around soil and how we can better use soils in urban communities for food production and for other purposes. And at this point, I will be bringing other speakers on the stage. So if you want to turn on your cameras, and you can join us for a quick Q&A session. And I'm just conscious of the fact that we've gone beyond the time we needed for the presentation, so we'll have less than about 10 minutes to have the Q&A session. But hopefully within that time, we can still provide more insight to the conversation. I was quite happy and really enjoyed all the presentations. Probably that's why I wasn't keeping very strictly to the time, but at this point, let's come on to review the questions, provide further insights. I don't know if Asmat and Bill Gay, if you can turn on your camera and join us, that would be highly appreciated. While they are trying to, okay, great. But waiting for Bill Gay to join, I think we can just, okay, great, good. We're all ready to go. So we've got about 10 minutes to rattle through some of the questions that's come through and some of the questions that I have, and hopefully be able to provide some further insight to the audience. So I think probably I'll start with the question which we've shared with the audience, and that question is, where do we see, or what kind of innovations do we see very important to help advance the food system to ensure access to good food to more people as we move on in the future? I'll invite everyone to speak at this point. Feel free to go first. Okay, Carl, please. Putting you on the spot.
Well, that's actually a really tough question, I think. It's for me, it's difficult to point to one particular thing. And as we've discovered through our project in analysing multiple different technologies, it's very context and use specific. And so, for example, something like UAV spraying in vineyards works on hill vineyards when you're replacing people with backpacks who are highly exposed to pesticides and insecticides. It works very well, but in a flat vineyard, for example, it doesn't pay. And so it's difficult to say, oh, I think this technology is the thing that'll make the big difference. Although I have a general feeling that anything that supports decision making has a long future. But anyway, I'll leave it there as a starter.
I don't know. I mean, you use the acronym UAV, unmanned autonomous vehicles, right? Just for the benefit of our audience.
Oh, yes, sorry. Uncrewed aerial vehicles, drones. Yeah.
Okay, yeah.
I
who want
can
to
go.
go next? Feel free, yeah.
Sorry.
Please.
Thank you. I totally agree. It's more like a topic specific, and also like what we are talking about. For instance, clean cooking. Like when it comes to innovations, you should also, of course, follow the regional popular trends. For instance, right now in Bhutan, for instance, they have reached 100% electricity, so which is an open window for actually e-cooking. So this kind of innovation technologies is really depend on, of course, not only like this one specific thing, but there's a different kind of energy projects, and also, as I told you, trends. So I think it's more like a one specific part of the cycle, but more like it's just like following the trends and trying to find the open window for the opportunity.
Great. Thank you very much, Bioge. Please feel free to go next. Asma.
Yes. I think very insightful presentations from everyone else. So from our side, I think we feel robotics is going to play a large part, because a lot of the problems that were the barriers to entry for robotics was in terms of the cost of robots, and then like other related technologies, for example, communications, which are all developing together. So cost of robots have now gone down quite a bit, and we're looking at within the next few years that will be reduced further because of the higher production volumes that we are reaching now, and the communication technologies have also much more developed. So we're envisioning that robots will start to be on the fields. I mean, they are in some forms already playing parts in different research, but hopefully will be in more like scaled deployment in the next few years.
Fantastic. I mean, I don't mind the bias. Everyone must have presented the technology they're working on, so it's okay if you feel your technology is the most needed. We really appreciate that. But definitely, I'm sure we're making some very good points here. And if we have policymakers with us, I'm sure they're listening, they're taking note of opportunities where funding can be put forward to ensure that we can strengthen and improve the food system. Dan and Will, please.
Yeah, I'm happy to go next. I mean, I think there's not much I can say which is novel compared to the other responses. I think it's a case-by-case basis. There is, I think there was a need, though, if I might stress, from the perspective of the talk I gave around soils, whatever we do, whichever technologies we develop in the future, we must do so with robust understanding of the environment in which they're used and in which they're developed. So making sure that they are going to provide benefits to the wider ecosystem, and that we don't have any unintended consequences arising out. And I think that's where research and development of those technologies really comes in to the fore. So I think, I'll maybe hand over to Will at that point.
Great.
Cheers, Dan. Yeah, no, look, fascinating points from everyone, and I think I'd agree with what many people have said. It's hard to pick out one technology or one route that'll be important due to the complexities of food production systems around the world. But I think for me, robust systems are important. From having been stood with a commercial offering of an agricultural robot quite recently that you couldn't get to work because it's so complicated. And it's brilliant. It's a fantastic bit of technology, but having a robust system, which leads me into my main point, which would be rural connectivity and connectivity technology. I think it's very, very easy to forget. Anyone here that's had out on the ground experience with any technology like this, whether it's just remote sensing something and trying to transmit a small signal to actually the control of a machine, the connectivity is a big issue for me, because actually it adds so much cost into the system of every time there's downtime, every time there's an error. And we're struggling ourselves now with the ability to do remote service. We've got the capability on the machine to do remote service on a conventional machine that's not autonomous. We should be able to just dial in and see an error code and help the operator get moving and keep growing food. But connectivity is such an issue, and I don't think that should be underestimated, because if we don't sort that as a world going forward, none of the technology is really going to function or work, and it becomes especially important. I think the less and less people are involved in looking after agricultural technology and supply chain technology. We need to be able to communicate with people a long distance away to get things moving again.
Yeah, absolutely. I think in the face of increased labor costs and also shortage of labor, having robotic systems, unmanned vehicles, unmanned aerial vehicles that could help to a lot of work is quite important. But I think it comes back to what Dan was saying about what is the environmental impact. I'm conscious of aerial vehicles and what impact on pollinators and birds and stuff, and how we manage all that to eliminate that. So it's just being conscious of what we're manufacturing, what we're producing, and how it's impacting the environment. I just wish we can take a lot more questions, but I don't want to give us beyond the time for this meeting, because I'm sure people have important things to attend to after this. I'll just say, what is the one thing you want to say to attendees? You can talk to policymakers directly, you can talk to households, you can talk to farmers, whoever you feel you want to communicate to directly. Please just mention that sector and then speak to them specifically. So I will invite Bill Gates, go first.
Thank you. Actually, maybe like with one sentence or two in general, our work is based on how individuals can, of course, get better in different sectors, especially like the sector that I'm working in the energy transition. And the most important thing, of course, getting feedbacks for us to make the projects better. So it's really, really valuable if they can, because we are doing a lot of background researches and trying to find actually the needs all around the world. But if they are, especially like coming from an NGO or really interested in these kind of things, just getting feedback or like just to see the trends or opportunities within that country is really helping for us to shape the future projects with, of course, like with the appropriate fundings. And as also you mentioned, like in general, we don't want any unintended consequences. So that's why the feedback is really important. So you can always reach out to us and send an email, reach out to me on LinkedIn. And you can just have more information on this topic if you're interested.
Thanks, Birgit. Dan, please.
Thank you very much. It's putting me on the spot here, but I think, okay, so today's is about engineering sustainable food systems, and there's not many food systems that don't depend in some way, shape or form on soil. So as a soil scientist, as a keen advocate for soils, I would say, please consider the soils underneath our feet. They're underneath, often taken for granted, out of sight, out of mind, but we really should be thinking about them because they are the foundation upon which a sustainable and resilient future can grow. So I think we can cultivate that future. We can use innovative engineering solutions for that, but that has to be germinated in the wider ecosystem, which I think fundamentally comes down to the healthy, productive, sustainable soil resource.
Fantastic. Will, please.
Sorry, my audio cut out a little bit. What was the question or the statement?
One last comment, one or two statements you have for any stakeholder across the food system. It could be farmers, policymakers, households, whoever you think you can speak to.
I think on the subject of engineering sustainable food systems, I'd focus on the engineering part of that and say there's so many opportunities to get involved yourself and get involved in the engineering of that. To whether it's to policymakers, to anyone studying, to anyone really, don't overlook it as a career because it's fantastic and there's so many opportunities. It probably doesn't get the whether it's soil science to designing, the bearings and the metal and the belts on machines. It probably doesn't get the kudos that some of the other sectors do. So yeah.
Fantastic. Asmart.
Yeah, thank you. I think it's great to be here and contributing. For myself, I feel that this is a huge opportunity for the industry, for everyone to come in, and we are in this novel time. And as a proponent of advancing innovative technologies, it would be great to collaborate and to build new things which are working. We need to collaborate deeper. With all sorts of technologies, and none of these technologies would be working along by themselves. It would have to work with other technologies, everyone, all the systems have to be working in parallel and be successfully deployed for an efficient system. So yeah, I'm looking forward to more collaborations in the industry, especially for robotics. It is a very collaborative system, so we need collaborations. Thank you.
Great. Thank you very much. And Professor Carl Bell, Erratic.
Yeah, thank you. Thank you very much for inviting me. I've really enjoyed this afternoon. It's been really interesting. I might say two things if I can, really quickly. One would be there's still a lot of uncertainty about how innovation interacts with sustainability and how we monitor sustainability and healthy food systems in a way. It's still evolving, and I think there needs to be a lot more work there because some of the interactions can be long. But when we switch to something like regenerative agriculture or conservation farming, it can be 3, 4, 5 years before we see the full effects. And I'll be interested to hear Dan's thoughts on this. So that's one. And the second one is making policies that consider these long-term interactions. And so understanding the data, monitoring what's happening, and putting policies in place and understanding how regulations interact with development. And that's one of the key things that's popped out of some of our work is that some of the regulations that are in place are designed to protect the environment, protect people, but they're actually having the reverse effect when they're applied to certain technologies or innovations. And I think there needs to be much better understanding there. So I'll leave it at that. Thank you.
Fantastic. Thank you so much for your contributions. And I think that brings us to the end of the webinar today. It's been a pleasure to spend this 3 hours with you all. And I hope you found it very useful. And there are so many actions for you to take away from here, and also opportunity to network with the speakers going forward. So thank you for joining us today. And thanks to the speakers for the amazing presentations. Really appreciate that. Thank you.
Thank you.
Yeah. So it's been a great day, and once again, congratulations to the participants selected for the Global Agri-Food Techpreneur 2025. We look forward to working with you in the next couple of months, and we do hope that you will be able to get the knowledge you need to be able to support the transformation that is very much needed within the food system. It's been a pleasure to be here with you today, and I hope you enjoy the rest of your evening. Thank you for attending.